it's okay to record. They will be acknowledged on YouTube pending review of all the information and making sure we don't have any hiccups along the way. We're just double checking a few more things here.
Yeah, that was okay.
Perfect. All right. So good evening. Just to make sure that you're in the correct group for this evening's presentation. We here are known as the San Diego SQL User Group. Thank you again for joining us. And again, thank you for your patience while we just chatted to make sure everybody's in our group. I am Rebecca. I'm the organizer, and this is my lovely husband, Eric.
The co-organizer.
Okay, and we here in the San Diego SQL Server Users Group provide professional opportunities to stay on the forefront of the Microsoft Data Platform technology stack through education, networking, and sharing of this information. As always, we do welcome feedback from all our members. If you have any questions, comments, or suggestions, please feel free to message me through the Meetup app or via the chat room during this meeting. Our presenter, John, has asked us that we go ahead and hold off on asking questions. He will break periodically to give you that opportunity to disclose your questions to him, and he can basically answer them as we go along, keep the channels free-flowing. So each session, as I mentioned earlier, is recorded and it will be available on YouTube, just in case you missed some of the details. We do ask that you respect our presenter and our group in a professional manner. So tonight we do have our very special guest presenter. So let me introduce you once again to John Miner. And the presentation tonight will be on practical data engineering with Spark. And I know he's going to go into great detail with that. So we do hope that you will learn something new or valuable and apply it to your career or your passion. John, thank you once again. The virtual floor is all yours.
Okay, thank you for having me.
You're welcome. It's our pleasure.
So I'm going to do a little sharing and then I'll turn off my mic. This is the kind of introduction to get to know you type thing. So I said it's a pajama party, so I'm almost ready for bed. It's 9:30 on the East Coast. It's only 6:30 area, and I've been up since like 7, so it's a little tiresome for me. This is my picture, and actually I present this already for pass, okay? But I'm going to minimize this. I'm going to show you some links, okay? If you're curious, hopefully this is year number 8 for MVP. I've been proud to do that. It would have been almost a decade if I didn't go join Microsoft, but that was a great experience. I spent 2 years there. Okay. I'm an avid writer, so if you like what I present, please go to MS SQL Tips. There's about 90 tips there, and I keep on adding one a month. So, kind of one of my passions. Okay. Second thing is you might want to write this down. GitHub, John Miner 3. It's my repo for everything that I talk about. There's a ton of presentations. The one tonight we're going to be talking about is transition your T-SQL skills to Spark. Okay. So ADB, what is ADB? Azure Databricks code samples. Guess what? Everything that you're going to see tonight is here. What are these 2 different, or 3 different file types, right? What you're going to learn about them, I'll tell you right now, okay? Inside Databricks, there's a UI, right, which you can craft programs. They're called notebooks, okay? And they're called IPython notebook, okay? These are Jupyter notebooks, okay? So I did save them as that format. You can also see them in a Python program. .py, okay? Last but not least, Databricks supports a exports, a compressed database backup, okay, of content. And so the PySpark talk here. So all the details right here. You can go get it. Like I said, if you go back up, you even have the presentation, abstract, and some files for AdventureWorks, okay? So with that said, this is our Databricks cluster, and this is what we're going to work tonight. If you haven't seen Azure, you just go to portal.azure.com, you log in. I used to go in to handle crafty DBA because I like crafting stuff, beer, I like doing woodworking. So that's there, and that's about it. So enough about me. I'm going to go here and hide my camera. Okay, there's going to be sections in the presentation. I'll just pause and say, hey, is there any questions? And if there is, then I'll take them. And Eric, if you can just tell me at that point, hey, there's a question about this, I'll answer it.
Yep.
So again, about myself, John Miner, I work for a company called Insight Digital Innovations. And once in a while, I'm on Twitter. You can catch me at Pass. I actually did a video for Pass on data engineering best practices. Really cool stuff like project planning. Who does that, right? Might want to write a roadmap down before you build the house and so on. But there's a lot of other topics in that presentation. I'll be also presenting the same deck. So why are we here tonight? I'm going to be talking about transitioning your T-SQL skills to Spark, okay? And what does that mean? Well, you have SQL skills. I started, SQL back in 1987. We're talking about, the high school with Eric and his wife just recently. It's like, wow, that was a long time ago, right? But, those skills are still valuable, and we'll talk about how to use them. So, what is the purpose of this talk? Okay, many companies are moving their workloads from on-premise to operational data stores, right? That's what we used to have, ODS, right? A big, throw a SQL Server box there, throw a bunch of memory, throw a bunch of disks. You maybe have a couple terabytes, and guess what? We have a decision support system or ODS, right? A lot of people are moving to data lakes. What is a data lake? It's just cheap storage, right? And guess what? You got a lot of files. How do I process files? Well, Spark came about 10 years ago, okay? And it's a key player in this transition. So like anything, we don't want to start over from scratch, right? We don't want to, go to Spark and, start, learning, everything with Scala or Python from the beginning. We just want enough to do our job, right? And that's what we want to do. So we want to leverage those SQL skills that you already have to get into this growing segment of work, okay? And today I'm going to talk about the concepts and code that will help you during the transition. So, topics. What is Spark? Okay. Well, I'm definitely not talking about Leonard Nimoy, even though I love Star Trek. Okay. Second thing, what is a data lake? It's not like, your backyard pond, right? It's just basically, like I said, that cheap storage with a lot of files. Okay. Well, if we're working with files, we need to know how to work with files and folders because that's going to be part of the data engineering effort that you're going to be doing, right? So not only do you do, SQL to transform these files, but you're going to have to know how to copy a file from one place to another, how to rename it, how to collate it, so on, right? Well, it's going to talk about reading and writing data, okay? Last but not least, we don't want to go ahead and read and write data with data frames all the time. We want to actually take it to the next level. So we're going to talk about the Hive catalog. And that's a way to actually put in front of those files the semblance of a table, okay, or a view. We're going to review some SQL constructs. We're going to talk about some SQL functions. I'll just point out some simple known differences, but there's a ton of differences. And if you do start your journey, if today's talk is the first journey into big data and to Spark, then you'll definitely learn more about the differences. Okay. So what is Spark? Spark is a unified processing engine, okay? It was developed by in UC California, okay, so out in the West Coast where you guys are, and or folks, should I say, and it was by Matthias Zacharias. He's one of the founders. There's another guy that you always forget his name, but it was done during their dissertation for their PhD, okay? And they said, there has to be something better than Hadoop. The way Hadoop worked is you would read something in memory, you do a map reduce, and you have to write it back out to memory for each operation. So if I had 5 different operations, I'd have to read and write things to disk and then back to memory 5 times, right? And that can be time consuming if you're working with a terabyte of data, right? But with Spark, everything's in memory, which is awesome, okay? But there's 4 other components other than just data engineering. So I'm going to start the left and work clockwise. So we have SQL and data frames. What is that? Okay, when you read a file and it goes into something called a data frame, it's almost like a pandas data frame, okay? And you can think of it as a table, but it's just basically tuples, right? Rows of tuples. You got rows and columns. That's it. Second thing you can do is, guess what? This is all that stuff that came out with these, brain trust like Harvard and stuff, which came out with, the machine learning, like scikit-learn stuff like that. If you've probably heard, maybe. And so you can do machine learning, and there's ML ops in here. They call it ML flow and so on. Streaming. What is streaming? Well, it's not like, swimming down your backyard, in that lake. Streaming is sending stuff to the internet. It's the internet of things. How do you connect stuff, right? So I got this little device out there. It's your refrigerator. And you ever see the Maytag commercial in which the guy opens up the door and he looks in and someone's looking back at him? Well, imagine if you had a camera and then every time you open it up, it took a picture, right? And of course, this is made up, but guess what? You could stream that image to the cloud. Or you could stream, hey, someone opened up the door and closed the door. Or maybe every 5 minutes send the temperature to the cloud. It could be an operation that it's on a machine some type of operation plant, that making widgets and they're streaming data, right? Well, that data can go to a data lake, and guess what? Apache Spark can pick it up and put it into a table so you can start actually playing around with it. Last but not least is the graph component. How many people have been in computer science and actually have done graphs, right? The graph is like the classic one I think about is a traveling salesperson. You got someone that needs to go from, say, John needs to go from San Diego. He's in Providence right now, and he has a friend in, Ohio, and he has another friend in Texas, and he has another friend in Colorado. And what's the best way to go? The shortest distance, maybe, if he's driving. Or better yet, if he's doing plane flights and we get all the tickets, what's the one that's the cost of least? Or there's a priority on a delivery, right? Which one do I need to go to first, right? That's a graph problem, okay? So there's four major components part of Apache Spark, and um, what's interesting is it's made of thousands of lines of code, 600,000 lines of Scala. Okay. With that said, I'm going to open a question up, see if anyone's paying attention to the presentation. Does anyone know what Scala is? I'm
Anyone?
hoping Scala, Scala.
I think it's a programming language.
Yeah, and you got half it right, but what's it based on?
I guess that a Java language or Java virtual machine language.
Yes, it's actually based upon, okay, object-oriented Java, okay? And that is really important because that flies into the next slide, okay? Everything in Spark, okay, is done with a Databricks cluster. And I'm talking about Databricks. There's also Synapse has a version. Everyone has a version of cluster of Spark out there, right? Databricks happens to be the market leader. But the thing is that it's all cheap virtual machines that have a lot of memory, right? Remember I talked about in-memory processing? So usually a cluster is made of at least one driver node, okay, and one or more executor nodes. Now there's a special version of it in Databricks called a single node, okay, single standalone, and it has both the driver and executor on a single node. But more than likely, it's one driver plus how many nodes you have. So if this one has 5 nodes, okay. So how do you get charged? In Azure, you'd get charged for 5 virtual machines, okay? So that program just wrote, say I had a program that said spark.read, reads up a file, and then I say data frame dot, select this, and then I only want 2 fields, and then I do spark.write, and I write it back out. How does that work? Well, the program goes to the driver, right? And what it needs to do is it says, how can I make this go faster, right? And so if there's some partition already, maybe there's 2 partitions, might try to see where the task executor is. This is slots, right? This is where it can put some type of execution program. And each one of these happens to have 2 slots, and that might be the true representation of the hardware. It may not, but this is how it works when it runs, okay? And the slots are for parallel execution. And the thing is that how you divide up the data and how you store it and how you partition it and distribute it actually helps on performance, okay? If I, for instance, now I'm going to give you a quick example. There's 4 computers here, right? 4 computing nodes, okay? And each node's a GAVM, right? And we can see each has 2 slots, right? So say I had a program that was partitioned in 10, okay? How many tasks would I have to run for this to complete? It'd be 2 sets because I could not fit it and run all the data through one set of executions, right? I'd have to have another set of tasks and a job, okay? And so if I actually partition by 8, it would fit perfectly. In this one, this example, it shows that 5 of the 8 nodes are actually being used. Okay, so is Spark like, SQL? And the answer is a little, because just because you wrote a program, how does it operate, right? Well, it operates by the Databricks optimizer. So the optimizer is going to take either the SQL code that you wrote to query, a data frame we talked about. A data set is for those strongly typed languages like Scala, okay, or R. And it takes that in, the code, and says, okay, what do I need to do? It comes up with a logical plan. Then it resolves it. It has to look at the catalog. There's something in the catalog, so it needs to find the file where the catalog's based upon. then it optimizes the logical plan, then it comes up with a physical plan, does some costing just like SQL Server, and eventually selects a physical plan. But the main thing you should get out of this, and you shouldn't do, is work with RDDs. You should know what they are, but no one works with RDDs anymore. It's low level, and these optimizers are great. This is where, you know, the power of Spark has come over the years. Like there's Photons, a new version of the engine that Databricks come out for optimization. Okay, and these code generators are really smart. So they're a lot smarter than you trying to work with RDDs. So what is an RDD? It's a resilient distributed data set for in-memory processing, okay? And this plan that you come up the, you know, Python program becomes a Java bytecode and then gets executed on the cluster, okay? The main difference between open source Spark and Databricks is the optimizer, okay? Let me give you an example of an RDD. Say I work at a company, we did great this year. I'm gonna give everyone 5% bonus, right? And say the data is stored in a Python file, okay? Well, when we read the data from the file into a data frame, that's going to be one RDD because it's resilient and it's immutable, okay? So the second thing is, say I want to take salary equals salary point 1.05. That's a 5% raise, right? Guess what? That's another data set in memory in RDD because I couldn't change the previous one. It's immutable. I create another one. Last thing is I write it down and I don't have to do anything, okay? So that's a little about how the optimizer works and how things internally in memory are working. Okay, so right now I'm about to go into the Databricks service and give you a walk around what's out there. We talk about workspaces, clusters, importing files, the Hive database, notebooks, and jobs. Before I get into that, does anyone have any questions?
Anyone?
Nothing in chat right now.
Awesome. I must be either doing a good job or everyone's sleeping.
Both.
So maybe a little both, right? So when you look at these environments, there's many different things to do, right? I'm gonna you can deploy things with ARM templates, okay? And what I did here in Azure is I've created two groups, okay? One group is where the resources for Databricks are stored. I have no control over this. This is called a managed resource group, okay? And then there's also an unmanaged resource group, and that's mine, right? And the unmanaged resource group, I deployed three things. Let's take a look at it. First, I deployed a storage. This is our data lake, right? We can see that there's some data out here, right? And we can see there's a bronze level and there's a dimension, and this is the VentureWorks database. We got a CSV file. If we wanted to talk to this, we could. Okay. I also have a key vault. Does anyone know what a key vault's used for? Any takers?
Nothing in chat.
Okay, so key vault's used where you put secrets, right? You can also put certificates and you can actually do keys, okay? But the main thing we want to do is store our secrets there, okay? Usually you need three pieces of information to mount to remote storage. You need to have, okay, a tenant ID. That's the ID of where the storage count is. Then you need to have a client ID. That's your service principal and a password. And if you encrypt in it, you might have something like a Fernet key, okay? So that's just a little overview. And last but not least, this is the workspace. When I click on the workspace, we're going to jump right in here and we're going to get into Databricks, okay? Let's take a look. So the good thing is I did start up a cluster. Wow, that's a pretty big cluster. I didn't know I spotted up that much. 24 cores, 84 gigabyte of RAM. How many nodes is it? Maybe three? Yep, it's three. So it's 2 times 8 cores, right? And another 8 core, and then the 28 on each, okay? You can also see there, they've changed it. Recently, if we go back to a prior version, okay, there was 3 modes: single user type, that's the one I told you was there. There was high concurrency and there was interactive, right? Now they have this thing in which there's different choices, and I'll go over them later. Okay, the big thing is we did see that this is kind of beefy, right? And we came over here. This is the unmanaged resource group. I didn't refresh it since I got in here. Do you think something changed here? And the answer is yes, because if we go into this resource group, guess what? It spun up those virtual machines. This is where our workers are, okay? So this is our cluster. So we can see that there's 1, 2, 3 real virtual machines. And if you're curious, if you're a Linux guy like I was when I did my undergraduate and master's at the University of Rhode Island, you can see that it's actually running Linux, Ubuntu, okay? And it's 8 vCPUs, which we saw in 28 gigs, okay? And we can tell where it's running, East US 2. Okay. So let's go over the environment. This is the Databricks, they call it the control plane, okay? Let's go over to the very top, data science and engineering. So one thing you can do is, how do you get data in? Well, the easiest way and the laziest way, if you want, is you can just import a file, right? So let's see if I can find a file. So let me see if I have some junk hanging around. Do I have stocks around? Yeah, I got some stock data. Awesome. So this is S&P 500 stock data, right? And where was it? And again, I'm going off. Does anyone know what this guy? Stock symbol? Amazon, right? Yes. So we got some Amazon data. Let's bring that in. Let's see what we can do with it, okay? So I'm going to browse to it. Okay. C drive and stock data. This is old. I did this like 5 years ago, but still good data. I mean, it didn't change. It's historical. And whoops, went right by it. I was not thinking about it, and it hit open, okay? At this point, it's going to bring it in. You know what's funny is they keep on changing things. This wasn't there a week or two ago. So every time I look at it, it's like suddenly something new. So it's coming in. It says preview data. It's taken a long time. This is all new. So before, okay, it would come in and say, hey, you want to create something or not? And this is saying, hey, you got Hive data, made a data store. Do you want to create a table out of this? Is the data. They're trying to make it more seamless, okay? And there's different things like configure access, grant permissions, review SQL warehouses. I could just say for the heck of it, like, hey, why not? Let's create a table. And what's going to do is first it's going to copy the data in. Then the second thing, it's going to run a command that says create table, and it's going to give it the schema of what it guess at. It's called the schema inference, okay? And then it's going to create it. And like I said, this wasn't here a couple of weeks ago, so they keep on making changes. I think this probably got released with the Unity catalog, which was like 3 or 4 weeks ago. Okay, so at that point it says, hey, it's been put in, and guess what? We have some things in the Hive Metastore, right? The easiest way to query data, right? I'm gonna go a little off script and then we'll get back on script. Is say I was a user, say the Crafty DBA, right? And I want to create a quick program to do that. Well, we talked about notebooks, right? This is the UI. So I want to say, hey, San Diego. Gonna probably, how you spell San Diego? It's too low.
DIEGO.
DIAEGO.
No,
Yeah.
no, DIEGO.
Yeah, DIE. That's
There
what
you
I
go.
thought. But I'm like, it didn't look right. But this time of night, never know. So so there's a couple things. First, I could say, hey, make it a Python notebook, right? And if I hit confirm, it's going to say I can run Python. And if I want to do like print and hello, right, that's valid Python, right? That's valid Python. But say I'm a SQL guy. I'll say, hey, convert to SQL. It's going to say, oops, look what it did. It put this in. It was smart enough to know that you had Python before. And now you want to run SQL. So if I want to run this, you say, hey, %, that's a magic command. It says, hey, I want to run this Python. So if I do control enter again, it still runs Python, okay? But the main reason I wanted to come here is I wanted to do, for instance, SQL, right? And I don't even have to do this, and I could do show tables, right? And if I hit this, guess what? Hey, it shows me the tables in the default database, and I see one that's called Amazon. So now if I want to look at it, I can do select star from, and depending on how fast everything's going tonight, we can see, whoa, there's a high and a low. And I, again, don't want to get too off track because I do have the scripted. Let's say if I want to do the min of the open and the max of the open, for the whole year, right? Okay. Now, I did say that this is actually different. So if you bought in sometime, you could have gotten it at 750, but it was some point during that year it was at 1200. If you day traded, those were the high and lows that you want to buy in, probably sell at, right? So now if I'm here and I do this, how do I get the top 10 records? Does anyone understand how to do that? Can I put the top command in? What do you think?
I think is you can sort by in a descending order, and then you limit records to 10.
Yep. So the thing is, it's almost like MySQL. So you're gonna have to look at your syntax. So you could do this, right? And you can limit by 10 and it automatically is ordered. And then you could, for instance, if you wanted to, like you said, order by, say the open place ascending, we could say, hey, what were the days that had the lowest values? And we can do this, okay? So now we're treating that file exactly like a table. And there's your SQL skills, right? So let's go over the rest of the stuff. So what do we have? Workspaces, right? This happens to be a users count. Tonight, we're going to talk about the PySpark talk, and we're going to talk about reading and writing files. I'm going to skip over the New York City taxi cab example. It's quite big, and I don't think we have enough time for it. There's refining the lending club data we're going to talk about, and we're also exploring the lending club data, okay? One thing they also did, which is new, and they didn't have before, is before over here, when you came into Notebook, we created this Notebook, right? Oops, why is it not going away? Go back. We have San Diego here, right? But the thing is, say if I wanted to, nope. See, this is MLflow here. See, they changed all this. They don't have it here anymore, but they used to have the ability to say, hey, check it into like source control, right? You can't do that anymore. But no, what you can do is you still can do it at the file level, but I don't think the option's there. You can create a folder here. This is in repos, and what we can do is we can add repo, and we can connect this to a Git repository like Azure Data DevOps, and at that point, we give it a repository name, and anything we drag over, it's actually going to do pull and push request, right, automatically for you, okay? So that's the better way to do it, okay? So like I said, they've been adding changes to this all the time. Data, okay? This is your catalog here, okay? And there's different commands like show tables, okay? Show table extended, create database, drop database, all those things work, okay? And we can see that, like I got star schema and this is the AdventureWorks here posted, right? And we got MS SQL tips. This is the New York City tab that we're going to talk about today. And we have some files here, okay? The compute. This is where you actually go ahead. If it ever shows up, it's going slow tonight for some reason. I don't know why. Okay, try it again. Yeah, hopefully they're not doing maintenance because it'll be a really short demo night if they are doing maintenance tonight. Here we go. This is where you can create clusters, okay? So I have one that has table access control, okay? What's different with that? Let's take a look. Something called shared, okay? So let's try to create a cluster and see what's different. So the thing you might say is, hey, John, Spark takes a long time to process, and why is it taking so long? Well, the problem is it has to spin up all those VMs. They're not just sitting around because, you really want to check this off right here and say terminate after 30 minutes. Because if you have an exploratory cluster and your boss gets a bill of $5,000 at the end of the month, he's going to say, what are you doing? You'll be, oh shit, I left those 12 nodes on. It was a lot more than this. It was 128 cores and a terabyte of memory. You just sat there all month, and guess what? You get a $5,000 bill. He'll yell at you, right? So the better way to do is, unless you need something up all the time to do stuff, you use an interactive, okay? But the problem is there's a penalty to start it up and start it down. So say I start a job and I have a batch, right? I want to run one job after another. How do I make it so that the jobs can run one after another without actually incurring this 3 minute to deploy all the VMs, spin them up, and then say, oh yeah, it's ready to process, right? Well, that's where pools come in. So if we come back here, we have job clusters. That's things that run. So I had a job run here, and this job was actually loading some data. And you could see that, if you go into it, we talked about logs, everything's in here. So if you go into Spark UI, it'll eventually pull it up. It might take a few minutes. I'm not going to go there, but this program, if we went into it, we could see, did I get rid of the program? Maybe not. We can see, okay, this is printing some stuff over and over again. So we can see this is still running. Is this still running? Because it shouldn't be. Maybe it still is. Again, they changed stuff, so succeeded. So, okay, so this one, none. So job benchmarks, none. So I'm going to kill this trigger because it looks like it's still running, so pause. Okay, and you can see that the job cluster started coming out of here. It could be carved out of that pool, okay? So that's going to make it start up a lot faster. Okay, so we're going to get back. I think I did a really good job of kind of give you an overview of, what Databricks is about, okay? I'm going to hide the presentation view. I think I didn't do that last time. There we go. Okay. So I'm going to pause. Does anyone have any questions?
Floor is open.
Okay. So,
We have none.
yep. And if, there is, tell me. I'm more than welcome to pause and, explain something if you don't get it. What is a data lake, right? Well, a data lake is what we talked about. So you might have once a night, I go to the mainframe, right? We were talking about mainframes, Eric, and maybe we're pushing data up to the cloud and we're doing something with it. And maybe I have to talk to DB2, and maybe I'm using Azure Data Factory to pull data from DB2, right? And that data suddenly miraculously shows up in my ROR zone. What is a ROR zone? Well, there's two ways to describe quality. Okay, someone way back when said, "Hey, I like metal. Metals are expensive, right? So bronze is cheap, silver's a little more expensive, and gold's really good, right? And guess what quality is? If you got raw, it's really bad quality, right? And refined means, yeah, I started taking that, and maybe I smelted down the iron, but still has impurities. And, gold, which is curated, guess what? Not only did I refine all the impurities, but maybe I bonded it to another metal type, and just like stainless steel, you bind two types of metals to make something better, right? And that's what data quality is. So you're going to be pushing data from one zone to another, hopefully, not only cleaning up the data. So in this first zone, you might have it as CSV file. Second one, you might be using something called Delta tables. And the third one, you'll have curated, which might be a limited data set ready for reporting, or maybe it goes into an AI process in which you're trying to predict the future. Okay. So this is from Databricks came up with this diagram. I didn't, but it's kind of cool. Okay. So I have to do some justice about talking about data lake. If I don't say data dictionary, someone's going to yell at me, especially my boss probably at work, but she loves data governance. But a data dictionary is really important, right? You can keep track of where all the files are, but there's a lot of jargon in there. Like the glossary might even be important too. I didn't put it in the slide deck, but say if your definition of, on-time delivery is totally different than other companies, right? You have to put that down, right? Because otherwise you're not talking apples and apples, you're talking apples and oranges, okay? So use a data dictionary, and guess what? Use naming conventions. If you name conventions, standards on directories, folders, and files, then guess what? You're going to already start inherently have it documented, and the data dictionary is just going to add more information to it.
So
Okay.
is batch data, I'm sorry, is batch data lake or streaming more common?
They're both there. Okay. It depends. Whoops.
So
Keep
Sunny,
on
do you
hitting
want to
my
elaborate
buttons.
on your question?
Yeah. So I think in my last job that I'm more responsible for the batch data pipelines. So I'm not sure if the streaming data pipeline has more requirement. I think it's used different like big data tools to utilize it.
Yep. So I can tell you more about streaming. Streaming means that somewhere out there, there's something called a Kafka Event Hub. Okay. Event Hub means that it receives events. And what is Kafka? Kafka basically takes payloads of JSON documents, right? Java notation, right? Set notation. Okay. So you got this data coming in to the queue. Okay. It's piling up. Okay. What does streaming do? It reads off the queue. Okay. And then what it does is it process it. And a lot of times they take the streaming data, they not only land it to the data lake, but they also at the same time ingest it into a data table, a file format, and a Delta table, so you can actually query it real time. Okay. Um, I don't see that many people do streaming, but there are points which people do it. For instance, in hospitals, there's a um, format. I forgot what it's called. I'm gonna guess. I think it's called Firestorm. And what is it? It's for HL7 data. Okay, it's streaming HL7. It has its own format. And what they're doing, they're getting that from like vendors for lab reports. And what they're doing, one client that we have at my company actually is ingesting the streaming and putting it into the data lake. But the majority of it that we do is batch. Another company I worked for, you probably use their hand sanitizer products. I can't tell you who they are, but we just convert them from USQL to a data lake using Databricks. And guess what? Everything's batch. It runs once a night. So I would say that 90% of stuff out there is probably batch because that's what people are familiar with.
Mhm.
But the streaming feature is really nice.
Yeah, sounds good. Yeah, I think I'm just going to apply learning this streaming data pipelines later.
Yep, it's really good. And make sure you don't mess up those checkpoints because otherwise you're going to mess up all your data.
Yeah, I think they are like these two types of data pipelines, data lake is quite different.
Definitely. So let's talk about various file types because it's really important to know these, right? There's going to be weak file formats and strong file, okay? And I love strong file formats. And guess what? I love Apache Spark and Apache Parquet most of all, okay? What's weak file? Okay, a CSV file. Okay, it's great. It's easy to make, right? Guess what? Easily broken. I put an extra comment in, it doesn't work. Suddenly the whole thing breaks, right? Also, guess what? Eric's wife's really nosy about my salary, and guess what? It's in the CSV file. She opens up. Oops, I know what John makes, right? It's easily broken, right? You can break into it. It's not binary, right? Also, we have to guess that data type. So, say I got my social security number in there. Well, maybe I live in a country that has alphanumerics in their social security number. Maybe I'm guessing Sweden. I don't know. Maybe they have alphanumerics. I don't know. But regardless, right? It says SSN. I don't know what data type is. I have to infer the data type. To infer the data type, that means like with a JSON file or a CSV, if it's huge, I have to read the whole file all the way to the end to finally know that the very first field that's SSN is really just numeric data. It's 9 digits long, right? Versus if I went ahead and or 11, and then if I went ahead and it was alphanumeric, I would have to wait until I hit the first one, right? That said it's not alphanumeric. So that's why I hate weak file formats because they're easily broken. On the other hand, strong file formats, Apache, it's great. It's binary. It has a name and a field, so I don't even have to have a header record, right? Not only that, it has the data types, right? And last but not least, it allows you to compress it and partition it. And partition is really good, right? Because for Databricks, we're looking for partitions. So that's why I like strong file formats, and I suggest you use them in your data lake. Load patterns. Well, there's really two, maybe three different load patterns, right? We'll talk about them. Very first one's the full load design, right? Guess what? We got this United States file. We truncate it and reload it. Guess what? That's it. It's done. And it doesn't change, right? So you could run it every night or you could try to do an upsert, but the 50 states are 50 states. You probably only need to load it once it's reference data, right? Other things, maybe you had, let's talk about healthcare. Say we have models of like, I don't know, wound care dressing, right? My wife's a wound care nurse. Guess what? Maybe we got a new model. Every day we pull down the products we use in our wound care center, right? That could be a full load because it's a very small file. Okay. Now let's say that we're pulling in all the bills for a major hospital, say like Mass General, which is one of our clients, right? And at Insight, and we go ahead and we go to load it, and guess what? It's huge. It's 4 terabytes of data. Do we want to bring that up to Azure every day? No, it's huge, right? And it also costs a lot of money to do that, right? Because you're moving stuff around. So a better way is to do an incremental load, and usually means that you get some type of window, a hash or a partition, right? In this case, a daily update file. Okay. The problem with an incremental load, though, is that you still have to do either multiple incremental loads, maybe with a larger window. So instead of a daily file, maybe say, hey, I want 2 years of data in a data lake. So, and I'm going to load the first 24 months by month. So then what I'll do is I'll go to the source system, say it's Epic, and I say, hey, your medical Epic system, give me 2 years ago, January, I'm guessing 2020, right? January, give me all the data, right? I get one file and I load it in to Delta, and then I pen the second file, it's February, and so on. We do that 24 times, and guess what? We finally caught up, and then next day we can just get our daily file, okay? But when we get into these largest data sets, and what we really want to worry about is partitioning, right? How the pattern of accessing the data is there, okay? And that's a whole different class and talk in itself. Okay. Delta file. Why does everyone like Delta files? Well, because a Delta file makes it look like a table. It supports ACID transactions, okay? It does schema enforcement. Hey, don't break my schema. If we get a new file and you put a new field in, blow up, right? Cool thing about it, it's using log files. So it allows for point in time, right? So we can do time travel. We can go back and say, hey, what was the file look like yesterday before I added 5,000 rows, right? Before the Delta file format, we had to worry about snap isolations, right? So say Eric's writing a program to read up, I don't know, again, we're going to go with medical employees and give them a raise, right? And John at the same time tries to write the same program. We might have a collision, right? Locking of a file, right? It's only a file system we're working with, right? This allows for multiple readers and writers, the way it's written, okay? Last but not least, it's open source. This is the best thing since sliced bread within the last 3 or 4 years that came from Databricks, okay? Databricks came out with the Delta file format. Okay, let's talk about the Databricks file system. We saw it was Unix, so guess what? You have to learn some Unix commands. So ls is a Unix command, list and then temporary directory. It shows me what's in that directory, right? There's a different way to do it too. There's a dbutils, which is a Python program, .fs.ls. Now this %fs I said is a magic command. There's lots of different magic commands. The interesting thing is that %fs in turn interprets this and says, hey, pass /temp to dbutils. So it already knows what to do, okay? Now, I call it a local file system. Guess what? Me and a Microsoft engineer got in a little tiff. Uh, I consider it local because I don't have to mount it, okay? Or I have to set permissions to do a pass-through, okay? He's saying it's remote storage. Guess what? Everything in Azure is remote. Everything's make-believe, right? It's some computer somewhere else, and guess what? You have to instantiate an object, right? I have to instantiate Databricks, and what it does is somewhere it's smart enough to say, hey, deploy the control information for the plane, store it somewhere. Hey, John wants a Databricks system, and here are the users, right? Nothing's really physical anymore, right? So a local file system we're going to work with tonight is something I don't have to mount, okay? The other two ones, you have to use something called a hot mount point, okay? And so, for instance, if we're writing an old-fashioned Python program, first and foremost, if you write anything that's not Spark dot something, read or write, right? It's going to more than likely run at the executor node unless you use something like Apache Arrow, and that's a whole talk in itself. My friend Brian Kafiki, I'm just going to throw a name, give him a little cred here. He has a whole series of articles or videos on YouTube, his own channel on Databricks, and you can read all up about Apache Arrow. Nice thing about it is you can take programs that are written in Python and make them distributed, okay? There's some limitations on that. But when we use Python, like in this one to the right over here, we can see that we had to put that DBFS, Databricks file system /temp. We can't do it just like ls temp. It has to be dbf.temp. Same thing with this, sh. That's a shell command, okay? So let's get into our first demo. We're going to talk about reading and writing Spark files. We already did it kind of behind the hoods. They've kind of did it now with the Unity catalog, which they don't even show you the code they write, but I'll show you how to do it. The main thing, spark.read. Guess what? Reads one or more files. Spark.write writes one or more files. And what we're going to talk about reading and writing. We're also going to throw a bunch of file system commands here. So this is another great breakpoint. If you have a question, please speak up.
Floor is open.
Okay, so I'm going to go up to shared. Okay, and shared, this is our PySpark talk. We have to get the right talk. I talk about a lot of things. Here, and then what we're going to do is read and write files. Okay, so the very first thing you have to do, they don't show it anymore, is you have to go ahead and attach to something. So it says, oh, well, I had a standard cluster, and guess what? It doesn't exist anymore. So do you want to connect to Interactive? It's like, yes, you need a cluster to do anything. Okay. Second thing, this is called a markdown. So in reality, it's a %MD. But when you get away, you know what it does? It does some cool things. You can do hypertext. So I got a little icon. This is the crafty DBA logo that I go by. You can put anytime you write code, I have like this best practices talk I'm talking about. You should put some things in here like, hey, this is the name of the program, right? Who did it? When did you do it? What's the purpose, right? And so we're going to go through each one of these, okay? So the very first one, sample data sets. Well, the cool thing is and again, I'm running out of time, so I'm going to skip running some of these things. I'm just going to run the key ones. I think they're important. But if I did FS, LS, Databricks datasets, what is this? Out of the box, Databricks has a bunch of sample data, like for instance, the COVID data sets, airlines, Amazon, so on. So if you want to learn stuff, just look at the data sets. You can play around with them. Okay, they're free for you to use. Second thing is, guess what? Instead of doing FS command, when you do different commands using different ways to do it, say like FS is file system, SH is shell, you get different output. So you can see this is actually a data frame, right? It's basically looks like a table, right? And in a table, you can download, you can attach to a dashboard. See, this is all new. Before you used to be able to do like new visualization, and now I have to tell it what to do. Before it was like an easier ways to do it. So they changed the whole interface. One of these days when I get bored, I'll have to spend time with it. Or if I get a project,
So
again,
John, Sunny's asking, so I guess you can just use percentage to indicate which language you use in each block.
yes, you can. So you can go back and, for instance, we were talking about SQL, and say he was really wanted to know right this minute, hey, John had a star schema, right? And we want to do select star from star dot fact underscore internet. Let's go sales. Is this going to work? I'm going to find out. And guess what? It will work. And there you go. So it suddenly pulls to back the data. I happen to know that I posted this here. Like I said, this whole inter thing, like, see, there's a bunch of things like, hey, it's truncating. Know what they used to do, and I don't see here anymore, and I have to figure out where they hit it. I saw it there for a second. Is they also tell you like how it ran, right? I guess it's way up here. So we can see this is the data frame that came back. And remember I told you a data frame has properties, that's that. We can also look at the job and how it ran. Remember I talked about stages in which you had like task slots and stages? Well, this ran in one stage, so it only took not that much time to do, okay? So back to the core, different operations doing the same thing come out with different results. So we can see COVID's here, but it's formatted differently here. And this one says, hey, you know where it's supposed to be. So I don't have to tell you over and over the full path. I can just tell you, hey, these are the files. Okay. The local file store, when we uploaded something, okay, it actually goes here. So if we went here and run this, we can see that that Amazon FY219 file is here. Okay, that's where it ended up, and then it made a table over it. Okay. What I want to show you is the power plant data set. So if we do ls of the power plant, it's going to show you that there's 5 files. Cool thing is we can run a bash command. See, there's even more, and a bash command is a double magic command. And they don't even advertise this, but this is part of the Jupyter Notebooks language. And if we do a cat, I'll run this. This is a cat means to catalog, and it's just going to show us the data in it. So there's 1, 2, 3, 4, 5 different values, and it has to do with some type of power plant with pressures, right? What is it about? Well, we can say if you looked around here in this file back here, on one up, right? If we went back here, I'm going to go a little off here, and I'm going to go do this. If I remember right, shell command, I think that's a comment. And then if I go here, we probably get the README file there, I bet. And we do. See, it's a README, and then we get the data file. So what I'm going to do is I'm going to use, okay, it's going to run at the executor node because it's plain old Python. I'm going to say path equals there. And I'm going to say with open the file, and then take all the lines, join them, and then print it. And all I can do is I can see what's inside the files, right? So it tells you, hey, where it's from. Also, if you go to where this URL is, you can pull it out. And I was just curious, hey, you know, Miles document it, like T is for temperature. So if we go back, this T is a temperature, AT. V, what is that? Volume, right? So is that pressure? V is exhaust vacuum, okay? Goes ambient pressure and so on. So we can get all the information by looking it up, a lot of these files. Let's do some Spark. We've talked enough about how to, you know, do simple stuff with, you know, data. Let's actually read something up. So I'm going to say, hey, read up the power plant data. Start at TSV. So I want them all. That's the path. Spark.read, the format's a CSV. I'm saying it's a header. I'm saying it's tab delimited. Quotes are quotes. I'm saying, hey, guess at the schema because I don't know what it is. Load it, and I want you to partition it in memory in 4 buckets, okay? I display it, and guess what? Now I suddenly get these. This is our data frame. It says, hey, they're all doubles. And guess what? That data that we saw way up here that we couldn't really do anything with, we just catted it. It's off a file system, right? It's like a, you know, type and DOS, right? Now we have it in a data frame. We can do stuff with it, okay? Well, next thing we want to do is we can remove stuff. So we can say make new directories, right? And again, I'm not going to run this because there's some stuff there, but this would be, you know, create like a brand new data lake, like RISSUG is my Rhode Island SQL Server user group. Now it's called the data platform group because we really do data platform stuff most of the time. We can also run this command. It's like, hey, what's in here, right? What's in the bronze directory? And we can see there's the green taxi cabs in New York City. We got the lending club. We got the power plant, rate code. All this stuff isn't from that sample directory, but I just moved it over to the Rhode Island if I was going to talk about it. Okay. I'm going to talk tonight because, you know, again, there's a long version of this, which is almost 2 hours, and a shorter version is like hour and a half, and we're going for the shorter version. We're going to remove some target directories, okay? So power plant we're going to talk about, and lending club, okay? And the lending club is like an investment club, okay? So I just removed the targets of these two. So now if we come back here and we saw that there's, where is it? Lending clubs right there, and then we got the power plant. If we run it, those file directories should be gone, and we see it actually reduced. So we know that the RM works, right? Another command, we got copy command, so on. How many records in here? I don't know. Well, guess what? DF is the data frame. I can say, hey, run, give me a count, right? And I can concatenate it. And did I not write it right? Did I? DF plant is here. Let's try this again. Maybe I messed it up. DF plant's there, and then DF plant dot count. And maybe I just didn't run it. Maybe I just showed it to you and I didn't run it. Thought it ran though. There you go. So there's almost 50,000 rows here. Okay. Now, last but not least, I want to save it. Okay. So let's do. I'm going to save it to the power plant as a bronze directory because we want to kind of like do a pseudo fake data lake, right? This is now a real data lake because it would be extended storage, right? Remote storage in Azure Blobstar, right? It would be Databricks file storage, right? But we're going to write it as a Parquet, overwrite it destination, okay? Now, can someone tell me how many files you think this is going to write? Any takers?
Throw a number.
What? 0, 1. It's not 0, right?
4.
4 because that's where it was 4. And the interesting thing is I wrote a little utility program. If you go out my code out here, there's another talk, you'll see it. And what it does, it says, hey, write it to a temporary directory. So I'd do power plant / temp, and I'd put it there, and I would say, okay, find all my parquets and make it as 1, because a lot of times you get this, right? But for now, or especially CSVs, because most people want CSV as output. I don't know why people in love with CSVs, but whatever, you know, it's the business requirement. I do it. But I love Parquet. So this is 4, and this would be great for a cluster that had 2 nodes and 2 slots, right? You just run one job and you read it right up and you snappy, right? We can also see it's using compression snappy. Okay. What file formats does Spark.read support? Avro. It's another compressed format. You can read all about it. It's good for reading fast versus Parquet's like in the middle for like reading and writing fast. And then there's Orc, which I'm just guessing you should read it, but it has its own properties. They're all a little different. And so, you know, you use one at a certain time. Like if you're looking for speed when reading, use Avro. If you just want, you know, something that's ready to go into Delta, use Parquet, right? It does JSON, does text. Text is interesting because everything comes as a line, so then you have to somehow break it up, right? And then there's JDBC. That means you can talk to anything out there, okay? So let's go back to the slide deck. Okay, so we talked about read and write files. We got a few more and then we'll finish up. But I definitely want to cover enough so that you can get those skills going, those SQL skills. Processing files. Weak files take more time to process because you have to infer it, right? Consider passing a DDL, so data definition string. Basically, hey, the schema. 3 fields, they're all doubles. Boom, done. Also, you have to understand what you do with the corrupt brackets. Do you handle it? Do you stop the whole process, arrow it out? Something you have to figure out what you're going to do with. Working with SQL. Okay, Spark SQL, okay, PySpark. Runs under Python, and what it does, it has create and drop statements for the following: databases, which is a container, right? Metadata, tables, it's a description of what a file is, views, combining one or more tables using SQL and maybe doing some aggregation or indoor processing, are all supported by Hive, okay? Spark.SQL, what does it allow you to do? It allows you to take this SQL that you've done by hand and actually execute it and return back a data frame, okay? We already talked about the magic command allows for static execution of commands. And what's the cool thing is if we did spark.read a file, and then we did df create or replace temp view, this creates a temporary view. Then we can refer to everything using SQL. And that's the trick because now once we do spark.read and we do create a temporary view, everything else we can do is treating that file as a table. Okay. I'm not going to get into the managed New York City cab data because it's too big. You can play around with it yourself. There's some interesting examples. And the code that I have out there, I actually took some data that was corrupted. I don't know if they did it on purpose, but I reread the original files and then fixed it, okay? Working with data frames, okay? So there are a lot of functions that can be called with data frames, okay? For instance, one was df.select. Hey, I want to reduce the number of columns, right? So instead of having 100 columns, I only work with 5, right? With column. So I want to reformat or I want to create a new column. Maybe I'm putting a static value in, then I'm going to update it later. Or maybe I want to do something else, right? Where, okay, we talked about reducing the width. Now we're reducing the height by reducing the number of rows, okay? So please refer to documentation, but this is example 3, which is the Lending Club data, and that's what we're going to focus on tonight. So we're going to go back into demo mode. And we had read write files there, go back to workspace. We're going to skip this, we're going to go right here. Okay. So we can do an FS, LS, and again, it's connecting, so we have to say, okay, more, and that attach, and there you go. Hopefully it attaches. I was thinking something slow tonight. It's usually not this slow.
East Coast weather.
You know, I hope they're not doing maintenance. We'll see. It happens. They do maintenance on these clusters, and it is after hours in the East Coast, so see, it's still thinking. Okay, finally, but why here it says connecting? Kind of bug in the UI because they changed everything. It's all new. Probably broke something, right? So we can see that there's one file. It's a CSV file, 2018 Q2, and then there's a text file, right? So again, we can sh to cat the text file and we can get a bunch of information about it, right? So we can go down and, that's about it, I think, on the info down here. Don't see anything else. We can also do a head command. This is like Unix head and tails, right? In certain languages, and we can say, hey, let's look at the first 5,000 bytes. We can see, hey, it's comma delimited, right? Okay, cool. But there's a lot of fields in it, right? So what we can do is we can, if you wanted to create something again, and I'm not going to do this, you could remove the folder, right? And then create bronze, silver, and gold. And then we could say under Lending Club, remove it, and then we can create it new. I already delete them, remove it, create new. And then what we want to do is we want to copy these over. So this one I'm going to have to do says remove existing bronze, and then remove existing silver and create it. And then we're going to create a copy command. So now if I run this, it's going to do some things. Now, one thing I can show you is, guess what? It's always good to have error handling. I don't want this to error out for instance, it didn't remove it because there's nothing there, right? I'm just want to create a new one. That's the main purpose of it. So this is kind of like defensive programming. That's really good. Last but not least, if we do, hey, let's look at the bronze, we should have two files, right? We should have, we copied over one file. We copied over this location to the CSV file. It's getting a little late here. And then last but not least, we can show the stuff in the bronze layer. And guess what? We can see one file. We can see the details. If we're curious, I'm just going to go a little off course here. And again, I can play with my demos because it is a demo. I can say, hey, let's look at the silver. Is there anything in silver, right? And the answer is it shouldn't be because we removed it, right? And so did I remove it? Silver. File directory silver. Yeah, it looks like, you know what? It might have not removed it because these are part of Parquet file, but we'll definitely drop them when we recreate them. So that's probably why I didn't get rid of him. Okay. So what we want to do is the very first thing is we want to read this in. We're going to show you how to work with data frames. So I'm going to read it in. I'm going to tell it to header true, and then we're going to display the data. Okay. So we're going to do this. And we can see that it ran the job, 2 stages, right? 2 jobs, and we got a bunch of nulls. And look, we got a lot of stuff here, like term 36 months. I don't know. I can't like figure out, take the loan divided by the months to get the, the amount because it's not numeric. So how can we fix this, right? I want to do some manipulation here. Like we also have like, percentage after rate. I don't want that. We got employee lengths, and guess what? We got NA, we got 1 year. I don't get this in numeric. So there's some cleanup we want to do, right? So if we do raw.count and I skip this, we get about 130,000 rows. How do we clean this up? Some data processing using data frames. First and foremost is when you use certain things, okay, and there you need to bring in the PySpark SQL functions, okay? So we're going to bring a bunch of functions in. Very first command I talked about was, hey, I want to select. So now I reduced this down to a handful of columns, right? If we look over here, the number of columns is quite lengthy. Okay, it's definitely not a handful, right? If we go up here, I don't know if it tells us the number of columns. It used to. Probably could do dfcolumns.count, but I'm not going to go that far off. No, what we want to do is we want to determine what the loan is, right? So there is a bunch. This one I'm showing you is the way not to do it because this doesn't leverage your SQL skills, okay? But we could say, hey, a bad loan is, there's a function called is_in. So if the loan status is current or fully paid, and it's not that, so it's not current, it's not fully paid, guess what? It's a bad loan. So that's going to return a Boolean value. Then we're going to cast it to string. So we'll either get true or false as a string, and we're going to associate with bad loan. We're going to do a reject replace. We're going to take that percentage sign and interest rate, get rid of it, and cast it to a float. We can do same thing with the revolving utility rate. Issue year, guess what? We're going to take a substring of it and cast it to a double. Earliest year, we're going to do the same thing. Okay, calculate the length. And what we're going to do is we're going to take the other two that we calculated, subtract them. See, we're making a new column. This is the width column, right? Then last but not least, we can do multiple passes against employee length. For instance, these are all reg. If it's less than 1, make it 0. If it's greater than 10, make it 10. Otherwise, do this pattern, get rid of not applicables. I'll let you figure out the rest. And last but not least, we display the loans and we repetition it and write it as a Parquet file. So let's run this. And it's going to run. So that was a lot of work, right? And you know, you have to learn a lot of functions like substrings, right? Regex replaces. You have to know about regular expressions. Just a lot of work. So guess what? We got it cleaned up, right? So we can see employee length is nice and clean. The revolving rate's nice and clean. The date is in here, issue date, so on. So it looks good. Okay. So what we're going to do is we're going to say drop the database MS SQL tips CAD and then create a new database. Okay. So I'm not going to do that because I don't want to delete all the other stuff that's attached just in case I have to talk about it. But what I'm going to do is I'm going to drop the lending club. And what I'm going to do is I'm going to write over this. Okay. So now what we can do is if we do this, Control C. Yeah, let's run the whole thing. What the heck? Okay. At this point, if we run it and get the top 5 records, we can see the interest rate now, the loan status. We made it fully paid versus current, right? And then if we go to end, we get a new field, right? So we got the bad loan is full, issue year, earliest year, credit length and year. So we see there's a little bug in that calculation, but that's because guess what? It's a 2-digit year, right? So we're going to have to fix that. We can see that the issue date is June 18th. It doesn't tell us, you know, what the issue is 18, but that's what year? Is it 1918? Maybe it's thinking that, not 2018. Okay. So, and then we can go ahead and do that. A quicker way to do this is remember this roar. Let's go all the way back to refresh our memory. Roar was spark.read. That's it. So instead of doing all this data frame processing, which was, hey, let's set loans equal to roar.select, and then we created an output, right? We're going to go back with roar again, but we're going to create or replace a temporary view. So boom, that's it. And now if we show columns in temp club, we can see there's 145 columns. Remember I was guessing at it? Don't have to guess now, right? Say if I want to look at the first 10 rows, boom, select, got the same thing, first 10 rows. Guess what? If I want to test my query, I can do the same thing. I can do select. I can do regex replace, which we did, substrings, right? The interesting thing is, unlike the other one, which it actually sets a variable and adds to the data frame, when we actually calculate length in years, we not only have to do the cast and substring for issue year up here, but then we have to subtract it for earliest year here to get our cast. Last but not least, this complex one is all one nested regex. We have the fields that we don't change. And then guess what? That one, which was the tilde, which meant not, we just do a case statement, right? Case when, and boom. So now if we run this, okay, this is actually going to show you the data. Problem is, didn't really do anything because this is all interactive, right? How do we program this? Well, we use a here document. 3 quotes means anything between here and the end of 3 quotes is string. So I took all that code, put it into a SQL statement. Okay. Then what I do is spark.read, spark.write, right? Or spark.sql. So spark.sql equals loans 2, repetition is 2, write it out. Boom. Now I have my second data set. I just wrote it out, right? Now we could do a ls and removed, right? Lending club, but we can say drop it. And then what we'll do is we'll repetition it, repost it, I mean, as a table. And then guess what? We can limit 2 on 2. And now we have 5 records, okay? So basically I showed you that if you take all the skills you already know, you can leverage them to do this type of data transformation. If you want to do the same thing with a data frame using Spark, you have to learn Python and know all the methods to do this, okay? So all those years of using SQL come in handy and valuable. Okay, any questions?
Floor is open.
Got one more slide and one more demo and I'm done. So if you got them, ask.
You got a comment that said nice.
Thank you. So last but not least, exploring a data set with SQL. I'm not even gonna make it full screen. I'll make it just for that, for the presentation, for the heck of it.
Can I still ask a question? Why do you have the repartition?
Oh,
in the list
because
example?
I just did it because I want to save it as 2 files. If I didn't, it's a default partition. Someone I was talking to recently, they were like, "Oh yeah, I didn't repartition it." Oh, it was a friend at work that I was working with, and she was like, "I did this. I didn't repartition. I didn't realize I suddenly got like 45 files." And I was like, "Yeah, because that's probably the default setting that someone set on the Spark cluster." Okay, so unless you say repartition 1 and you want a single output file, you'll get a single output file. But remember, I showed you I can go back to it, but after I'm done this demo, there'll be a couple extra files you always have with Spark. For instance, first write something called success. Then there's another file, it's called committed. They're usually 0 bytes. It has to do with parallelization and how it works, right? And then last but not least, you get something called part. Even though you have one file, it's always going to be a single partition, right? Has some type of weird GUID there, and then it has like .csv, or if it's Parquet, it's snappy.parquet, right? So it's up to you how many partitions you want. I like to control the parallelism, so I said, hey, I'm going to have 2 because I have 2 computers. Does that answer your question?
Yes, thank you very much.
It's probably more than what you wanted. The answer is I just wanted to.
Thank
And
you.
the per-
You're welcome.
Same person who said nice, said thanks for the overview. You covered a good array of tech there.
Oh yeah, there's a lot in here. I put a lot of tech in. I will show you a book at the end. It's sitting off my desk and you can go get it. It's a little old. I'm not pushing it. It's the guy that founded Databricks, okay? Yeah. He might not have something to say, but it has a lot of this. You can also go to Databricks if you don't want to spend the $40 and download a lot of this examples. So not all of this was taken. All this content's mine. I just developed over the years of the last 2.5 years I've been doing Spark. And I was kind of like you. I was a SQL developer. I picked up Spark. So exploring a data set with SQL, that's the last thing. This section is going to talk about reinforce the fact that, hey, SQL skills are applicable. And what we're going to do is we're going to do some simple and advanced constructs, okay? This is not too advanced, but we're going to do some windowing and some aggregation and show you how it works. And it used to be really cool, but I think they messed up my demo because now they have those diagrams, the graphs, and another one. So I don't know if it's still there. So we'll find out. It's what happens to tech. They change it on you. So this is the last one, right? We're going to explore the lending and demonstrate how to explore data. So we're going to go up and I can say show tables and MS SQL tips, right? And of course it wants me attached because I haven't attached it. It was an old cluster. And we can see that MS SQL tips only has 2 tables, right? And it's not temporary, which is kind of cool. So I'm going to skip over that. Why does it? That is really weird. Why did I do show tips here? But then I am talking about there. I don't know why. Anyways, for some reason, where did I get these from? Okay, so I posted the tips in here, but then for some reason I went back and looked at these in the New York City club. I think it's because at one point it was all in New York City, but then I changed this because I wrote a tip. So we could actually go off script and I'll fix it. I mean, again, it all depends. It's not really bad. If we go ahead, we can always refresh a table, see if it gets out of sync, right? So this should still work, right? And then also we can limit, and this was posted before, and this is the new one we did, which is 10 rows, right? And then we can do the same thing. That was a 1. We can say get account. So that's our 130 that we're thinking about. So we're going to use the second one that we did the data processing. We could have done the first one too. It's all the same, right? So I live in the Northeast. And if you don't know where the Northeast is, there's what, 5 or 6 states there: Rhode Island, Connecticut, Massachusetts, that's 3, New Hampshire, Vermont, and Maine. So we have an address state. We want to know if it's a bad loan. We want to count the number of loans. We round around the average loan amount to 4, and we just want to aggregate where the loan amount is greater than 0. Okay, so we just want to know what a bad loans for each of these states. And if we run it, we can get an output or we can make a visualization. Since they mess things up, I'm not going to change it because I don't know what it's going to do. But the visualization is probably not going to be bad. It used to be like It used to be a thing which you'd hit a button, it would go back to like a data frame versus a visualization. For now, for some reason, it's a visualization, and I don't know if I have to hit plus to make it go back to a data frame, which is kind of weird. But anyways, it's what they add. I'll have to figure out why they do this. See, it says add to dashboard. There's dashboard. So anyway, so we can see there's bad and loans and good loans, right? We can see the number of loans. And so we can see that Massachusetts has the worst bad loans, but has the most number of loans. So it's not bad. Rhode Island, on the other hand, has 8 bad loans, 612. This has 65. So the percentage here is probably they have a better rate of loan given than us because we don't give enough loans out in Rhode Island. Okay. So it might be something that you want to fix. Now, remember I said there was an issue with the year in which it was truncating it, right? So the problem is right now, if we went ahead and we did address state and we said earliest year, what is it? Well, if it's less than 50, more than likely it's 2000, right? 50, up to 2050. We could change this. We could say less than 40. Otherwise, it's 1900, right? So now if we run this, guess what? We're going to get the address state and the loan year and a loan amount. So we can see, hey, group by it. We can see how many, what year for this address state and what was the loan amount, okay? And it's just showing 100,000 rows. We know it's 130,000 on 1,000 rows is 130,000. So it'll take a long time to show you all of them. So we're not going to go into it. But I just want to show you this code because you know what? We need to fix the data we have to do something more interesting, right? Say we want a running totals, right? That's pretty standard, right? So what we want to do is that now we're going to make it more complex. So we're going to do it with CT. So it's a common table expression. We're going to fix the data first, right? So address date. Then we're going to get the year, loan amount, right? Then we're going to take that, right? Now what I want to do is I want to petition it, give it a row number. And I want to do address state and loan year and order by loan year between the unbounding and preceding road number as the loan ID. Just randomly given a number. Give me the address date, year, amount, and then what I want to do is a running total. So I'm going to do a sum over it, petition by, address date again, same thing with the run amount. And then I'm just going to order it by. So let's take a look at this. So if I run this one, okay, 633 rows. So we can see if this works correctly. It's Connecticut, 2011, 40,000. Going to add a loan amount of 3,600, so it's 40,300 and 43,600. Adding a 10,000, 53,600. Adding a 3,000, so on. And if I scroll all the way down, it's going to keep on incrementing this counter for loan number until it transitions to the next stage, right? Thinking Hampshire might be the next state, but I could be wrong. It's late. Nope, Mass. So Mass next day. So we can see that in Connecticut, it was only 15. Nah, I must have went over to another year. That's why went too fast. 2012, and then I'm trying to catch it right there. Right there, there was 59 loans given in 2012 to Connecticut, and it totaled for $684,500. Okay, so it's more like a small loan business. But that was the end of my presentation. I just want to summarize it, and then we can open it up and see how you liked it. So summary. This is all called modern data platform, okay? And usually you use something else to get the data, and we just started with the data somewhere in the data lake. It happened to be a local data lake because I didn't feel like showing you how to mount it. It could be here another hour or so teaching stuff. This is a Spoken Hub design. Why is it called a Spoken Hub design? Source data from producers can be either pushed or pulled into a lake. So I've written stuff in the past for people to say, hey, I want SSIS to talk to a lake and just dump stuff there. So that's pushing data in, right? Or more likely nowadays, people come to me and say, hey, John, I got an on-premise, data source. How do you get it to the cloud? And I say, okay, let's install a self-hosted integration runtime and use ADF. And as long as I have access to, say, SQL Box, DB2, whatever, Oracle, I can query the tables and pull the data into a file and store it on the data lake. And suddenly I can have incrementals and do all these patterns we talk about, right? The cool thing about a data lake, it's a subset of data, okay? And it allows you for these quick and investigational queries. I showed you, hey, spark.read, create temporary view, and suddenly, guess what? You can query it, right? Better yet, data scientists, there's many different types of users. So you got your data engineers modifying the data and aggregating it to do stuff. Then you got scientists who try and create models to predict the future, right? Last but not least, you can curate the data, right? And it can be given for analytic reports, right? The main thing I've found, okay, after the last 2.5 years doing this, naming conventions, okay? Make sure that objects in Azure are named, make sure the data entries are named, make sure the coding's consistent. If all these is standards and they're consistent, it's really easy for your team to understand it, the nature of them. It's documented and the system's really easy to maintain, okay? I talked about Azure Databricks, but there's plenty other alternatives over it. Nice thing about Azure Databricks is it's not only Azure Databricks, it's AWS Databricks, and it's GCP Databricks. But I want to point out, being a Microsoft MVP, Databricks is not the only one out there. There's also Azure Synapse that supports Apache Spark. Okay, regardless, the skills that you've learned, if you adapt them with a smattering of Python and a little Spark and SQL, guess what? You can learn how to become a big data engineer. Okay, and the future is definitely bright for those who can adapt. There's a bunch of references: Databricks documentation, SQL functions, data frames, local file system, and I'm going to open up the floor for any questions at this time.
Okay, floor is open. So it looks like, let's see. Nothing
I'll turn my.
Sunny mentioned earlier that she needed to do some hands-on projects herself. We do like your icon with the little hammer tools.
Thank you. So I'll let my camera up. I hope you enjoyed the presentation. Please look at my articles on, MS SQL tips. Always a lot to learn. I'm always learning every day. As I showed you, they changed the interface on me just like within the last few weeks. So I have to catch up. If you're interested, this is backwards, but this is the Spark, the Definitive Guide by Bill Chambers and Matthias Zaharia. It's a really good read. I haven't even gotten through it myself, but one of these days I will definitely do it, maybe the holidays.
Yancy says, could you post the links of the reference in the chat?
Sure. In fact, how about you do this? I'm going to give you the GitHub and you can download everything, and everything's in there, all the examples and so on.
Perfect. Sunny says, thank you. Sounds good.
Okay, it's in the chat right now.
Perfect.
And I hope you enjoyed it. Hopefully you invite me back. I do have a talk on how to use Synapse serverless pools, and maybe that'll be interesting to your group sometime in 2023.
Perfect. Sounds
absolutely.
great. Does anybody have any other questions before we let them go? It is actually almost 11 o'clock, approaching in Massachusetts right now, and those who are in San Diego, it's only 8. Lauren says, thank you so much. This was a great presentation. Again, thank you for our attendees as well. We appreciate you coming. Appreciate having John here. Max says, thank you. A very interesting presentation.
Excellent. Well, good night. Stay
Perfect.
safe, and the next time, take care.
Thank
Okay.
you once again, John. You have a
Thanks.
great
You're
night
welcome.
too. Take care.
Bye.
Thank you.
Bye-bye.
Goodbye,
You're
everybody.
welcome.
Goodbye.
Good night.